You know what? You were just so judgmental.
Okie dokie. How many people play cards?
Cards?
Yep.
Depends on what card.
Well, we're going to talk about probability today. We're not involving cards today, but maybe. It's using a deck of cards, right? When was the last time you thought about, listen up. When was the last time you thought about probability? Is it 7th grade you did it?
We did it. I know we've done it. We've done this.
Oh, right. Okay. Well, today we're going to talk about probability, but we're going to do it with geometric probability. So let's say you're playing, let's say you're playing darts, and you want to know the chance of hitting the bullseye. You can actually calculate your chance of hitting the bullseye. You find the area of the bullseye, and then you find the area of the full dartboard, and you set it up as, I'll show you, but you can do that. I'll show you. We're going to do it on the back side. Watch. Probability is the likelihood that an event will occur.
What is the probability that I will?
It can be written as a decimal, a percent, or a fraction, which I'm going to show you on the back side because we'll have a problem on the back. So let's say you're playing cards. What's your chance of pulling a queen out of a deck of cards?
4 out of 52.
Right, so we can write it as a fraction, 4 out of 52, right? Or we could write it as a decimal by doing what?
4 divided by 2.
Yeah, and then we could convert that to a percent. Generally, it'll be written with a percent. All right. So this is written as, sometimes you'll see it in the book as the probability of A. And when you see that, they're saying the probability of event A occurring. You say probability of event A. That's what that means. Now, for geometric probability, you have to set up a ratio that involves a geometric measure such as length or area. Just like we did 4 out of 52 for queen, we can do the same thing for area. The chance of, let's say you're jumping out of a plane and you have a certain small area to land in a big field. You can calculate your chance of landing in that area compared to the big field. So find the probability. First, we're going to talk about length, geometric probability using length. Find the probability that a point chosen at random on segment PQ is on the given segment. Express your answer as a fraction, a decimal, and a percent. All right, so first of all, we're looking at PQ. How long is PQ?
1, 2, 3, 4, 5, 10.
It's 10. You always have to know the total when you're doing probability. So then it says, okay, what's the chance that you choose a point between R and T? How many units is between R and T? 1 unit. So you would say I have 1 out of a 10 chance. Now you can make that a decimal. What would that be? 0.1. And as a percent, what would it be? 10%. Easy enough. Now, what's your chance of choosing a point between T and S? How many units are between T and S? 5, so it would be 5 out of 10. And you can reduce that to 1/2, which is what as a decimal? Or 50%. What's the distance between P and T?
1, 2, 3, 4.
So 4 out of 10, you can reduce that fraction. Would be what? 2 out of 5. Written as what? Does anybody know?
40%. Yeah.
0.4. And what's that as a percentage?
40%.
And then between R and Q. How many? 7. As a decimal is 0.7 and then 70%. Well, that's like way easy, isn't it? Okay. It gets better. Not much better, though. It's pretty easy, really, geometric probability is pretty easy. Okay,
So that was just normal.
so let's say you live in the city, New York. You don't really need a car. You got trains all the time, right? Let's say this train leaves every 30 minutes. It's not often exactly on the half hour or hour. You don't really know. It just says every 30 minutes. Your trip to the office takes 18 minutes. One morning you arrive at a station at 8:15 and you need to be at work by 8:45. What is the probability that you'll be there by 8:45? What's your chances that you're going to get there by 8:45? So there's some things you have to think about here. It could possibly be up to as long a wait, depending on when the train arrives. How long might you have to wait?
29 minutes.
Well, let's just say you could wait 30 minutes. Yes, 29 minutes. You could if you just happen to just have missed the train. However, in order for you to make it there on time, how long do you actually have to wait?
20, no, minutes.
Yeah, 30 minus the 18 that it takes to get there. You really only have 12 minutes to wait to make it to work on time. So your chance of making it to work in time would be the probability, I'm going to write this out, of getting to the station or to work by 8:45. And you're never going to see anything that long. I'm just doing it for the sake of teaching. Would be equal to the flex time you have to wait divided by the total possible wait time. Which would be 12 divided by 30. Reduce that to 2/5, which we just found that percentage on the other side. What is that? 40% chance. Well, it's not a bad chance.
I thought it was.
Okay, I thought it would be too.
Yeah.
A dart game uses a target with concentric circles of radii 5, 8, and 12 inches. So I look at my picture here. That means that this has a radius of 5, this has a radius of 8, and that has a radius of 12. Okay? A dart is thrown toward the target. If the dart is equally likely to land on any point of the target, what is the probability that it will earn 20 points? So you want to know your chances of landing in the bullseye. So all you do, just like in a deck of cards, your chances are there's 4 queens out of 52. Okay, you just find the area of where you want it to land, and you divide it by the total area where it could land. So the area that's favorable, you'll often see the words favorable in probability, divided by the total area. So that's pi times 5 squared. That's the area I want it to land in. Divided by pi times 12 squared. That's the total area. Look how easy this is. Those cancel out. So you really just have to do 5 squared divided by 12 squared.
25.
You don't have to, but I'm just saying you can cancel the pi's out. Approximately what?
25 or 144. Point. That is not likely.
And that's a what percent chance?
17.36.
Percent. Okay, so I did this one yesterday, but then today I looked through your review, and you don't have to do it if you don't want to. Sarah?
What does this have to do with the rest of the chapter?
It's
Like the probability.
probability. It's using your knowledge of all the area formulas and putting it into probability. Yes, that's why. Okay, so